After leaving the mixing head, the liquid moves forward continuously, and during this process it has to go through creaming, rise, and forming. If this section is not well matched, the first visible changes usually appear in the block shape, top flatness, and side condition. Let's start with the bottom paper and side film. They directly affect how the bottom and both sides of the block are formed, whether the paper and film run steadily, whether their position is accurate, and whether they are properly in place will all be reflected in the bottom and side condition of the block. So if the bottom looks uneven or the sides are not straight, checking the condition of the paper and film is usually more effective than starting by suspecting the later section. After leaving the mixing head, the liquid also passes through the overflow trough before entering the foaming section. What matters more at this step is whether the liquid can form a relatively stable transition state before entering the downstream section. If this part is not handled well, the problem will not stay in flow alone. The creaming and forming condition will also be affected. Next, there are three things that need close attention: the traversing frequency, the conveyor speed, and the creaming and rise rhythm of the foam. The traversing frequency affects how the liquid is spread across the width. The conveyor speed determines the forward movement rhythm of the foam, and the creaming and rise rhythm affects whether the foam can form stably under that coordination. Once these three are no longer well matched, the cross-directional distribution, top condition, and overall block shape will all begin to change. The settling plate directly affects top shaping. What it changes is the top restraint condition during forward movement, so the final top profile and flatness are both directly related to its setting. Different formulations and different rise conditions require different settling plate positions and adjustment ranges. If the top condition keeps showing repeated problems, this is usually one of the first places that should be checked. Now look at the conveying system itself. The main conveyor is responsible for moving the foam block forward steadily. The side chain plates are responsible for pushing both sides forward in sync, and the downstream conveying section is responsible for carrying the basically formed block further along the line. One problem here that is often underestimated is side synchronization. If there is obvious relative sliding between the side support and the foam block, problems such as rubbing, hard side strips, and side cracking become much more likely to appear. So what needs to be judged clearly in this section is this: after the foam comes out, can it be received steadily? Can its shape be stabilized during continuous forward movement? And can the top and side conditions remain consistent? When the forming section is well matched, the later cutting, curing, temporary storage, and transfer stages are much easier to keep in step. But once the forming section begins to fluctuate, what you usually see later is not a small local issue. It is the shape and condition of a whole section of product starting to become unstable. In the next episode, we will continue with the control system and look at why it becomes a key dividing line for long-term stable operation. If you want to understand the 7 key factors that affect the long-term stable operation of a continuous foaming line, please leave your email in the comments and we'll send you the document later.